My name is Gregor, and together with my colleague Petra, we're excited to host you today, and we hope you will enjoy our company. Let me first share some short technical information about today's webinar. So the session is, as always, recording, and the recording will be shared with you after the webinar, so you can watch it again and maybe share it with your colleagues. And of course, you're welcome to ask questions during the webinar. You can find a special section for questions and answers in the dashboard. Place your questions there and we will try to answer them at the end of today's webinar so that we don't disturb the flow of the webinar. So there are many of you who meet us for the very first time today. Again, we have a very impressive number of registrants. It's more than 150 of you registered. So we can see that the topic is interesting. So I would like to share some words about our company for all of you who don't know us yet. So we're essentially a software company that has been engaged in the digitalization of the built environment since its inception. So we have more than 30 years of experience in this field. We develop specialized software to support civil engineering design. And as said, today we'll talk about the design of water drainage on the roads. We're an international software company with offices in Germany, Czech Republic, Serbia. Head office is stationed in Slovenia, and we also have a worldwide network of partners. And we can say that our software solutions are used on all continents around the world. We're also an active member of the international organization Building Smart, and we contribute to creating and adopting open international standards and solutions for infrastructure. So our company also provides Building Smart education and professional certification for engineers. As a software developer, we advocate the open beam and standardized IFC data exchange. So our software promotes this. Maybe some of you don't know exactly what Building Smart organization is and what it does. So it is a non-profit and independent international organization that is dedicated to development of open beam standards for the digitalization of the built environment. And open beam standards enable us to efficiently collaborate and exchange digital information over different platforms. Open beam standards also support circular economy, the green transition, and decarbonization. The last two particularly are very important topics these days. So this is an important issue. And I would like to invite, maybe if you're not familiar with Building Smart, that you visit their website. It is on top on this slide. You can find URL and explore maybe their activities in details. If we go further on, so as a software developer, what we do is we develop civil solutions suite, and with this we provide solutions for civil engineers for three main fields. These are roads, railways, and river engineering. Most applications that we develop are for roadway design, and this is also a topic today. So CGS Lab software is used from preliminary designs to throughout detailed infrastructure design and creation of 3D and BIM models. as well as for the preparation of the project documentation. So you can use it throughout the entire process of the design. And now I'm handing over to my colleague Petra, who has extensive practical experience on the civil engineering projects and is responsible for the preparation of valuable content for civil engineers and users of CGS Lab software solutions. She will present several different approaches that you can use when designing road drainage. So Petra, please, the floor is yours.
Okay, thank you, Gregor, for this introduction, and hello to each and every one of you. I trust you're all enjoying a fantastic day. My name is Petra, and I'm a technical support engineer at CGS Labs. Today's session promises to be insightful, and I'm excited to have the opportunity to share valuable information with you. As we delve into the details of our topic, I encourage you to your active participation. So feel free to ask questions in the dedicated section here in the Go to Stage webinar. Write down any new commands and their functions in your planner and make the most out of this presentation. So in this webinar, we are taking a slightly different approach from our previous sessions. So it's shorter, but more focused, so concentrating on showcasing specific examples. So first, we will explore two ways to visualize the flow of water by drawing contours lines. I will also share a trick on how to draw arrows indicating changes in elevation. In the second example, I will show you one procedure on how to create a sewage system in Plateia. I will demonstrate how to use polyline editor and projection lines to display pipes in longitudinal profiles and cross sections. Additionally, you will learn about the new tool, Search CGS Elements, which streamlines the process of finding projection points, lines, 3D objects, and other entities in the drawing. And in the final example, we will explore drawing ditches using two methods. So the first method involves initially drawing the ditch in the longitudinal profile and then transferring and adjusting it in cross sections. And the second method is to draw the ditch directly in the cross sections. We will also delve into labeling ditches in the profile table, then proper editing of ditches, and what we should pay attention to during the refresh process. So for all of you who have registered for today's webinar, I have prepared a detailed PDF instruction for all three examples. So you can find them in the GoToWebinar application under the Hands-out tab, or maybe if you are using a web version of the Go to Stage webinar, then you will find them under the Materials tab. In the coming weeks, I will also upload videos of these examples to our YouTube channel, so I kindly invite you to subscribe, as this way you will be notified immediately when a new video is uploaded. Now let's look at the first example. So we have an intersection where we have already drawn 3D lines for the edges. I did this using the Draw 3D Road Edges command, which you can find in the Layout tab. Based on these lines, I will now draw the surface and I will display it as contour lines. Okay, so in the Layout tab, I run the Terrain command and define the terrain's name. Okay, and after that, I will select points and break lines, and then I will click plus button. So here I click plus button and select all the 3D road edges of the road. And note that if the road has a centerline crown, it is necessary to select not only the edges, but also the center line. After that, I check the box for the contours and I click settings. Here I have some additional settings for interval, for major and minor contours. Okay, so now we have the terrain, and if these lines outside the road bother us, we can also generate a boundary. So in my case, I have already prepared the boundary, and it can be either a 2D or a 3D polyline. So I run the terrain command again, select the boundary in the drawing, and now you will see a new terrain. Okay, so now we only have the surface of the road. And okay, now we have drawn contour lines on the road and we want to know which point is the lowest, so we will know where the water will flow. Okay, so we do this by first going to the top view and then clicking command label contours. In the command line, you can read, okay, select first point or settings. So I will first click on settings. It opens a dialog box where I select surface and define text height and number of decimal places. Okay, and now in the drawing, I specify the location of 2 points along which the elevation will be labeled. This line can also be moved and labels will adjust interactively. Okay, and you can now see where is the lowest point of the road and where the water will flow. Okay, and in Plateia, there is also another command that draws contours between two 3D polylines and indicates the slope direction with an arrow. So the command is called interpolate roadway contours. Okay, after running this command, we select first 3D polyline and then press enter if we want the contours to be drawn along the entire 3D polyline. Then I select another 3D polyline and press enter again. And in the dialog box, I click settings and I check the box for the arrows option. Okay, now next I can specify the arrow interval and height and click OK. And if I zoom in, now you can see that the contours are drawing on the roadway. And you can also see the elevation data and the arrow that indicates the slope. Okay, so now let's move to the second topic of today's webinar, namely designing a sewage system. So Plateia is a software solution designed for road planning and reconstruction. And it is not primarily designed for planning a sewer network. But however, you can utilize all the potentials of the program and define the sewer axis using various tools and methods. And how I navigate and which approaches I employ depend on me as a designer and my preferred method, sorry. And in the PDF tutorials, you will find two procedures. The first one utilizes the polyline editor, while the second involves using commands from the drainage and sewer tab. We will go through the first method together today, as we will be using some tools that can also be very useful for other tasks. So at the beginning, I use basic CAD tools to draw the sewage system on the layout. This involves employing commands such as spline for drawing pipes and blocks for drawing manholes. All of these elements are drawn in 2D. And after I define all these elements, I can select those